Welcome and thanks for joining. We have got a wonderful journey ahead of us, and we're starting on section 1.1. We'll get through a lot throughout the year. But section 1.1, before we get started, just to, re-clarify how these videos will work. A lot of times they're going to be split as sections of notes, which are things that definitely are mandatory. You have to make sure that you're watching those. That's where you're going to really get all of your information. And then there will usually be a second video where we're just talking about specifically the examples that are within those notes packets. One thing to just keep in mind is there is some flexibility there. In this video, for instance, I'll do a handful of examples just because of the nature of the topic. So the topic, what we're going to be talking about is lines in a plane. Now, lines are nothing new to you, and we're really not even going to talk about anything new today. So it's just going to be a total refresher, nice way to ease in. So, intro, the main idea that we're going to be covering is lines. The term line for us is always going to mean that it's a straight line. Oh, I should probably use the pen for that. A straight line. And that's important to keep in mind. If you go to college and take some higher level math courses, you'll talk about lines that are non-straight lines, curved lines, in a sort of different way than what we do. So, the slope of a non-vertical line is the ratio of the number of units the line rises or falls to the number of units of horizontal change from left to right between any 2 points. So that whole paragraph is sort of saying what you guys have always sort of thought of, rise over run. But it's also just the ratio of vertical change to horizontal change. And then just, something that you might want to jot down over here on the side. When we're talking about slope, another word that's sort of important to keep in mind, or phrase, because it's not a word, is rate of change. Wow, which I should probably try spelling correctly. I'll even fix that. So it's rate of change. And those are used sort of interchangeably. So when we're talking about rate of change, we are talking about slope. Some people just don't realize that those are the same. So moving along, the slope between 2 points, two arbitrary points that we'll label x1, y1, and x2, y2. As you move from the left to the right, the distance goes up or down a set distance. The line goes up, a set distance, which can be found by doing y2 minus y1. Since y is always the vertical sort of height of our points, and it goes right or left a distance of x2 minus x1. You have sort of a diagram here that's going on. If I have x1, y1, and x2, y2, the vertical change is the difference between your y values, and the horizontal change is the difference between your x values. So slope then is found by doing y2 minus y1 over x2 minus x1, which is really, again, just the change in y over the change in x. If you need to take a moment to draw in that little picture, feel free, pause it if you need to. So we're going to skip over this next slide. We'll come to that in the optional video where we'll do a little bit of examples of finding slope. And skip ahead. So slope. You have 4 options with what you can sort of answer when we're talking about slope. If it's rising from the left to the right, so as I'm reading the graph, I'm reading from left to right. If it's rising, then we have something that is a positive slope. If it's falling, as I read again from left to right, we have a negative slope. Again, I know this isn't really too new to us, but we want to be reminded. A horizontal line. When we're talking about a horizontal line, we have a slope of 0. So the actual value of the slope is 0. Don't be confused with saying like there's no slope. No is just sort of like a strange word. It's a slope of 0. Vertical line. So a vertical line is when we have an undefined slope. And something to keep in mind is that an undefined slope is some number divided by 0. That's always what's going to happen, because in a vertical line, we have no horizontal change. So our rise over run, well, our run was nothing. All right, moving forward, some example of an undefined slope. I am going to do a little example here, fun. So consider the points 3, 5, and 3, -2. So I'm going to have x1, y1, and x2, y2. Our slope is y2 minus y1, so -2 minus 5, over x2 minus x1, 3 minus 3. That gives me -7 on top, 0 on bottom. Anytime you get this 0 on bottom, our answer is that the slope is undefined. Just sort of a key thing here. When you're being asked to find the slope, do not answer a question like this with saying vertical line, because my question isn't what type of line is it? It's what is the slope of that? So the answer here is just undefined. Also keep in mind that any number, even 0, divided by 0 is undefined. So even if this numerator was still 0, we'd get undefined. 0 over 0, for some reason, we get some strange answers. We'll also do an example of graphing. So if I'm graphing a line, there's tons of different ways that you can graph based off of the information that you're being given. Here, what's being given to me is a slope of -1/2, and it passes through the point 3, 4. So I'll make a nice axis here. And I'm simply going to start at 3, 4. So go right 3, up 4. And a slope of -1/2 means I'm going down 1 and to the right 2. Again, rise, run. So I'm going to go down 1 and right 2. Or I could go up 1 and to the left 2. That's going to give me the same straight line. And we're just going to draw a line through that. Arrows at the end because it continues on infinitely. Notice here I didn't need the y-intercept, something that we're used to when we're graphing lines. I don't need that y-intercept. It's giving me different information that still allows me to draw this. All right, talking about y-intercepts, there's a lot of different ways in which we can write the equation of a line. So if we're writing the equation of a line, the most common one to us is slope-intercept form. That's y equals mx plus b, where m represents our slope, b represents our y-intercept. This one should be super common to you. It's what you guys are used to using, and it's your sort of standard, quote-unquote, form for linear equation. Point slope form, that one you may have seen in Algebra 1. That one is going to be y minus y1 equals m times x minus x1. And again, these variables mean the same thing. So x1, y1 is a point, m is a slope, and x and y are really just going to stay as x and y. We also have then what's called general form. General form is ax plus by plus c equals 0. And this is something that you've actually probably seen before, but what you've done to it then is solved for y to put it into slope-intercept form. And then we also have vertical and horizontal lines, which are just x equals a and y equals b. And that's for a given point, a, b. All right. Next slide, we will have a little bit of examples at the end of this slide. So the same line. If I just have one line or two lines that are actually the same, they're overlapping each other, those have an infinite number of points. Thus, they will seem, italicized, seem to have an infinite number of point slope equations. So just, going back again, there's an infinite number of point slope equations that I can write for a single line. However, when put into slope-intercept form, they'll all be the same. So for a given line, I can write an infinite number of point slope, but there's only one slope-intercept equation. So for instance, I just want to prove to you I'm not entirely lying, or lying at all. The line with a slope of 2 passing through 2, -3 also passes through 3, -1. So what we're going to do is point slope. Y minus y1 equals m times x minus x1. We're going to do it two ways. We're going to do it first with 2, -3. So I'll have y minus -3 equals m, which is 2, times x minus x1. So x minus x1 is 2. We could obviously simplify this, y plus 3. So this is our point slope equation. On the other hand, our point slope equation, if we used 3, -1, so here's x1, y1, would be y minus -1 equals m is still 2 times x minus 3. Again, we can simplify this and call it plus 1. Now notice, looking at these two equations, you'd be like, those are different, so it's a different line. But no, those are in point slope form, and they could be the same line, especially when I see that this slope is the same. So we're going to simplify each one of them by putting them into slope-intercept form. I distribute this 2, so I get y plus 3 equals 2x minus 4, and subtract the 3. Y equals 2x minus 7. That's slope-intercept form. On the right, I distribute the 2 and get y plus 1 equals 2x minus 6. So y equals 2x minus 7. Now I would see, even though the point slope equation was different, the slope-intercept form is the same. So this is just the same line. All right, we're going to skip this next page of examples. We'll do those in that example video. And then I think this is our last slide that we're going to be talking about, relationships of lines. So when we're talking about relating two lines to each other, we have sort of three options that we talk about. One, the lines can be parallel. And you're familiar with parallel. What parallel means is that they're non-intersecting and our symbol for parallel is these like two vertical lines. We can also have lines that are perpendicular. Perpendicular, there we go, which means that they're intersecting, but in the specific way where it's at right angles. And here you can see your symbol for perpendicular. These two things totally shouldn't be new to you. You remember them from geometry, you might remember them from algebra. And then your last is just that you have some intersecting lines at any other angle. And we don't really, talk too much about those because they just don't have as many interesting properties that go with them. When we talk about the slopes then of these lines, parallel lines have the same slope. So if I have two lines that are parallel, I know their slopes are going to be the same. Perpendicular lines have slopes that are opposite reciprocals. We'll talk more about opposite reciprocals if you don't remember. And lines that are neither parallel or perpendicular obviously have two slopes, just with neither relationship. So they don't have the same slope, they don't have opposite reciprocal slopes, they might have opposite slopes, they might have reciprocal slopes, but they don't have both of those, or it could just be totally unrelated. So we do have 3 other slides that come after that. Those are all examples. We'll do those in that optional video. I recommend if there's anything that you need to hear again, go back to it. Make sure that you really do. I recommend watching those optional videos. It's just a good way of refreshing. You can skip around. It's as sort of needed in those. Otherwise, make sure that you jot down any questions that you have and make sure you bring them to class so that you can ask them.